So that's already, I think, the third or fourth attempt to do that video on solar energy, and that's depending because I'm just talking too much. It's my favorite topic. So this time we will talk about the solar thermal, and I try not to talk too much. I want to give you an introduction to the irradiation in Mongolia. So you can see that red spot here is quite a good area for solar. Also Ulaanbaatar is good. It's between 5.2 and 5.6, and if you see it in the yearly kilowatt per hour per square meter, then it's between 1,900 and 2,000. I would like to give you a comparison to Stuttgart. So in Stuttgart for the year, it's roughly 1,100, but for Ulaanbaatar it's 1,800. That depends because Mongolia is the country of the blue sky. And here we have, I want to introduce the three different kind of solar thermal domestic applications only. This one just briefly because it will not resist the Mongolian winter. So this is a water tank, and if the water tank is outside of the building, that gives some problems, even if it's well insulated. So normally you can see them, but probably they're only used in the summertime for gear camps and so on. So I will introduce you to the plate heat exchanger, which works in the same way. However, the tank is in the building and it needs a pump. And to the function I will come later on. There's the other one, the evacuated tube type. So it looks on the roof like that. So you have your vacuum tubes here. So one vacuum tube, you have it here, is a, as the name says, it's a vacuum. So well insulated, and in the vacuum you have a heat absorber in the color of black, and then you have probably normally a copper pipe where is some antifreeze liquid inside, and these ones is then here connected as kind of a heat exchanger. Let me see what it says. Yeah, condenser heat exchanger to the, that's actually that part here on the top, and ignore that one. It's not hot water out and cold water in. It is another liquid which is cannot freeze, so antifreeze liquid. So it goes into the building, and then there should be that kind of tank for domestic use. So that's the inlet from the panel, from the heat collector, and that's the outlet. Here comes the fresh water in on the bottom, and here comes the potable water for the consumption in the house out. Some sensors here, and here you have the whole thing as a drawing. So how does it work? So you have the cold water in that circle here for the flat plate collector. So the cold water is moved through the pump and warms up here in that space, because radiation is warming up the inner space of that heat plate collector. So the surface here normally is black. Here you have a transparent glass. So it's like a greenhouse. It's a system of the greenhouse. And you have some temperature sensor to see already the temperature inside. And then that one goes through the heat exchanger, warming up that water in the tank there. However, sometimes in the winter time when it gets too cold, you probably need some conventional boiler which you adjust just on the other side, or also in the tank. So only needed for very cold temperatures, winter times. So I introduced to you the flat plate collector and the evacuate tube, and these on the bottom you can see that's the temperatures, and here on the left side you can see the collector efficiency. I don't want to talk about the black one because this is just an black tube, black bags which you use for solar hot shower or something, but it's not used in the domestic way. It's actually used for swimming pools in the southern hemisphere to heat up the swimming pools or have some hot showers. I want to talk about the flat plate collector and the curve, which is going down by 140, no more efficiency. We are concerned about that area, which is here, it's hot water and together with room heating 80. So the most efficient one, you can see it on the blue curve, is the evacuated tube type. Okay, so we have some maintenance issue. This was in Israel. All of these, also this one in Zambia, they have an electric heater inside. So both of them did not actually found out that here, because of the dirty surface, this is not working at that system. Also, that one is not working because of the broken glass. However, they only found it out when the electric bill went up. And so that's one maintenance issue. Then all what is staying here actually should be not of your concern if you have a specialized engineer who is doing actually the installation and the tuning of the system. So you really need normally to, if you want to have a solar thermal system, you need a specialized engineer. And however, later on, there will be another presentation on shading and orientation. I made a special presentation on that using some online software which you can use. That will be quite interesting for you. That is for PV and solar thermal. Okay, and then there's a lot of homemade solar thermal application on the market. They are maybe totally waste or only work for 1 year or two to 3 years. They should have some standards, and they should be written on the collector. Okay, so far that's from my side. The next one will be solar photovoltaic. Thank you for listening.